I have an A plus in this class. This is amazing for the entire semester, and the last moment they're like, JK.
No, I had like an A, and then I got a D minus in the final.
Yeah, don't do that. Danny, sit down, put your phone away. All right, so
Yeah, I got it download.
first off, we have the Isosceles Triangle theorem. Well, first of all, let's define an isosceles triangle, okay? An isosceles triangle, an isosceles, not an equilateral, an isosceles triangle is a triangle that has two of the sides that are the same.
It's two sides that are the same.
Okay, two sides. So this is an example of an isosceles.
Wait, so like, are those two colors on the left, those two different sides?
They're the same length. I didn't match colors, sorry.
Yeah, you probably should.
So same length. Question. If the definition of an isosceles triangle is that two sides are the same, is this an isosceles triangle?
Yes. Oh wait, something else.
Is this isosceles?
No.
Debate! Who says no?
No.
Who says yes? All right, people that say no, tell me why it's not isosceles. This one right here.
3 equal sides.
Because it has 3 equal sides, and I said 2 equal sides. Who says yes? Did anybody say yes? All right, Zayden, why do you think it's yes?
Because if we...
Danny, did you say you wanted a pen? Sorry, I didn't hear you earlier. Sit down.
It'll kind of focus if I stand up.
All right, then stop talking.
There's
That
a
doesn't help you
protractor
focus.
back here.
A protractor?
Yeah.
They sell those at the farming fleet.
Farming.
All right.
Here, you
He
want
says
it?
yes, it is isosceles. Say it again.
Yes.
Oh, you say no, it's not? Change your mind, Zayden?
I can't pick up the protractor.
Yeah.
Oh my God, shut up.
Ready?
Yes. Wow. What record was your football team?
We were 8-1.
8-1. Your conference sucks. All right.
Yeah.
This one right here. Isosceles or no?
There's 62 days till spring break.
Really? By water.
Still.
We were on the
I'll make it say
final.
63.
Can't get any.
Isosceles or no?
No.
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 You're all wrong.
Yes.
What?
And
Does it have 2 equal sides?
Yes.
Yeah.
Well, it has
Yeah, then it's
three.
isosceles.
Has
So it
three.
turns out
3.
all
That's not
equilateral
accurate.
triangles are isosceles, but not all isosceles are equilateral, because equilateral means all the sides are the same. And when all the sides are the same, all the angles will be the same. So when you have equilateral, everything is the same. And that is enough to call it isosceles, right? It's like, to get an A, you have to get a 90%, right? But on the way up to that A, you have to pass through B, right? So if you have an A, do you have better than a B?
You're going to Jackson,
Right?
you gotta go
If I've got an equilateral, do I have better than an isosceles? Yes, but it still counts as an isosceles, right? It is at least an isosceles triangle. The best name for it, though, is equilateral. Just trying to show you some weird stuff in math. Same thing is true for squares and rectangles, right? Squares have all the sides the same, 90-degree angles, right? They're quadrilateral. A rectangle is a quadrilateral with 90-degree angles, but all the sides aren't the same. So it turns out squares are rectangles, right? Because all it has to have is 90-degree angles and be a quadrilateral, right? But rectangles are not squares,
That's stupid.
right? Squares are rectangles that, grew up and got a degree.
Go ahead.
Something like that. Okay? I had a joke someday. I'm sick and my eyes feel like they're going to pop out of my head. If they do, don't be alarmed. It's fine. All right. So, isosceles triangles, when we're typically talking about them, look something like this, right? Two sides the same. Now, there's an isosceles triangle theorem, meaning there's something that we can prove about isosceles triangles that we can later just say, instead of doing the whole proof, I'll just write the theorem and we'll know that it's true, okay? So, it says, isosceles triangle theorem, if two sides of a triangle are congruent, right? That sounds like the definition of an isosceles triangle, right? Then the angles opposite those sides are congruent. So what does that mean? It means something like this. So if I've got a triangle, and I've got two sides of it congruent, like this, then what that implies is that I have an isosceles triangle. The opposite angles will be congruent as well. So that implies that. So if you have this, you get this for free. Now we're going to prove why that is. But if you have this, you get this for free. Always true. Okay? That's what the isosceles triangle theorem is. Now when we talk about the converse, we're talking about the reverse. So we're taking that arrow and we're flipping it around, sort of. It's not going to be a direct flip. I'll show you what I mean. So the isosceles triangle converse theorem, right, is the opposite of this. So it says if two sides of a triangle are congruent, that's what we started with, then the angles are congruent, right? We're going to flip those two things. So we're going to start with if the angles opposite, if two angles are congruent, right? If two angles are congruent, then what?
Then the sides opposite.
Yeah, well done. The sides opposite those angles, right? Not just any sides. It's not just, hey, you got two angles that are congruent. Great. Sides are congruent. Well, which ones, right? It's the opposite sides. Then the opposite sides are congruent. So that's the converse. Converses are not always true. You can't just take any theorem and flip it around and have it be true. But when you can, what we say is that it goes both ways, right? So we can put an arrowhead on both sides. So if we know this, that implies this. Okay? It goes both ways. So this is a theorem, not a postulate. Remember the difference between a theorem and a postulate? Theorem, we can prove it, right? Postulates, we have to accept to be true because how could they be anything else? ASA, SSS, all of those are essentially postulates. In reality, only one of them has to be a postulate. The rest, you can use that to prove the rest. We call those theorems. We're just going to call them all postulates for now. This is a theorem, though, which means we should be able to prove it. So we're going to prove that when the sides match, the angles match, right? Essentially. So here we are down here, and they've given us triangle ABC. There it is, triangle ABC. And they've told us that CA is congruent to CB. So that means this and this are congruent. So now we're going to prove that angle A and angle B are the same, right? Isn't that the theorem, right? These two are the same and these two are the same, right? So we're going to prove that. So, couple things that we haven't done before that I'm going to show you in here how to do. So, there is a postulate. Remember, a postulate is something that we believe no matter what, it just has to be true. A postulate that says from any point to any other point, you can draw a line and have it be perpendicular. So, from point C down to a point on AB, I'm going to draw a perpendicular line. What does it mean to be perpendicular?
To be intersecting at 90.
Hits it at 90. Now, I'm not going to draw it for real, because that's just a pain, right? But I should be able to draw a perpendicular line between here and here. So I'm going to do that. And the way we do that in words, right? On the diagram, very easy. You draw the line and call it 90 degrees, right? The way we do that in words is we say let. Like let there be light, and you create it. So we're going to say let there be, let's call this segment CD, such that CD is perpendicular to, what segment is it perpendicular to? AB. Now we have a shorthand to write CD is perpendicular to AB, right? So I'm going to write that in parentheses and we'll use that from now on. We could have just written this. Right, that's the sign for perpendicular, because it looks like the thing that you make when you make a perpendicular line, right? So that's just that in parentheses, right? I could have written that instead of CD is perpendicular to AB. It means the same thing, okay? So we've let that happen, and we're allowed to do that. There's a postulate that says you can create that whenever you want, okay? Now, does that mean that AD and DB are congruent, these two segments down here? It looks like they are, but does it mean that?
No.
We don't know. We could maybe prove that. Maybe that's another theorem, right? When you have an isosceles triangle, you drop a 90 degree, you get, a midpoint here. Maybe, right? We don't know that for now, okay? So you can't mark that these are congruent, even though it looks like they should be. Is that cool? Right, again, looks can be deceiving. So now we've done that. Do we have enough information to prove these triangles congruent? Because if I can prove the triangles congruent, then I know their parts are congruent, meaning that A and B are going to be congruent. Well, right now I've got a side and an angle. Is there any other information I can get here?
Doesn't the other one have to be 90 degrees?
That's a good point. We're going to get that next. What else do you see?
Shared side.
Shared side, baby. So we're going to write that. So we're going to write that CD is congruent to itself by shared side. Everybody cool with that? Remember that from the quiz, right? And now, for this triangle, looks like we have HL, right? We have hypotenuse and a leg. And for this triangle, we have hypotenuse and leg, but why can't we use HL for this triangle? We can use it for this one. Why can't we use it for this one?
Not 90.
We don't know it's 90, right? we've got a hunch, a strong hunch that it's 90. But we need to prove that first. If we can, then they're both right triangles. We use HL, and the triangles are congruent. Okay? The story for today is get as much information on your diagram as possible, right? Back up your reasoning. Then prove the triangles congruent, as many as you can. And then match up their parts to get what you want. That's the concept, okay? So, linear pair theorem, exactly. So, Luke is saying, I know this angle over here is 90. This has to be 90 over here. And he knows it by linear pair theorem. Remember, linear pair says if two angles are on a line, they is, right? They're on AB. Then they must be supplementary. And by definition, what does supplementary mean? What's the definition of supplementary? Not the same, that's congruent. They add up to 180, right? They sum to 180, right? Remember how complementaries add up to 90, supplementaries add up to 180? So, linear pair theorem says these are supplementary. Supplementary means they add up to 180. And if they add up to 180 and this guy's 90, what does this guy have to be? 90, right? By subtraction property, right? 180 minus 90, whatever's left over is over here. What? Exactly. So what we're going to write instead of doing the whole linear pair theorem thing, right? Linear pair theorem means this, definition of supplementary. It's semester 2. We can now just say this. By linear pair theorem, angle, measure of angle, what is that? CDA. Let's do ADC. Equals 90 degrees. We just cut to the chase, right? Linear pair theorem means they're supplementary. Supplementary means they're 180. 180 minus 90 is 90, so this guy's 90, right? We're cutting to the chase here. I bet you guys like that. It's a lot less writing. Does everybody understand the idea of linear pair theorem? And why it means that guy's 90? So now, let's prove the triangle's congruent. Which triangles? This triangle and this triangle. The left and the right one. Not the big guy. Okay? They're both right triangles. They're both right triangles. You guys got jokes. Noah! Good question?
Can we not use the Isosceles Triangle theorem?
No, because we're trying to prove that. Great point. So Noah, we're proving that, and then after that, all of this can be condensed to just say, by Isosceles Triangle theorem, these angles are the same. You see what I'm saying?
But
Like,
we basically know that the two sides are congruent.
yes. So we're pretending we don't know the Isosceles Triangle theorem. We're trying to prove it. So imagine, let's see, what's a good analogy here? Imagine you're out camping, okay? And you've got this blowtorch to light your fire, right? Now, we could use the blowtorch to light it. It'd be super easy. But I'm trying to show you guys how to make your own, right? That way you understand and appreciate the blowtorch, right? Basically, I'm teaching you how the blowtorch works. So if you're in the wilderness, you can make one on your own, and then you have a flamethrower, which you should be thanking me for, honestly. Only you can prevent forest fires. So, here's the flamethrower, Isosceles Triangle theorem. If this, then that. Boom, we're done, right? Makes this super quick. We have these, therefore those, right? We get the angles. So what we're going to do is prove that that theorem's true, right?
Because of HL, right?
Exactly, right. So we're going to write that by HL, hypotenuse leg, triangle looks like ACD is congruent to. Now when we write this, we have to make sure to match up our letters. A is this angle. It's made up of the hypotenuse and the unknown leg, right? Again, great band name, unknown leg. Hypotenuse and the unknown leg. On this triangle, we have the hypotenuse and the unknown leg. So angle A is going to go with angle B, right? So B. C is this angle up here, made up of the hypotenuse and the known leg. So C is going to be congruent to itself. And then D, well, it's the known leg and the unknown leg. Known leg, unknown leg. So it's congruent to itself as well. Now we're not done, because that's not what they asked us to prove. They asked us to prove this. A and B are congruent. So here's a new thing we're going to learn today. Here's the theorem, okay? If two triangles are congruent, meaning they're the exact same thing, that means their parts are congruent. You see what I'm stepping in here? It's like a duh statement, right? Right? If two triangles are the same, then they have parts that match up, right? We call that CCP, corresponding congruent parts. Corresponding means they match up together, right? Congruent means they're the same. So parts that match up will be congruent. So we prove the triangles are congruent. So if the triangles are congruent, we can say that their parts are congruent. Which parts? We're going to say these parts, right?
So
We're going to go back over this. Follow with me, okay? So I'm going to say by corresponding congruent parts, CCP. If you've ever been in Sunday school and you're dozing off, like I was as a youth and now, I almost became a preacher. Still might. Can you imagine?
Sunday school?
Yeah, man. So,
Oh, like you still go to Sunday school?
no. I don't.
When you were
Alright,
a
so,
youth,
that's right. Showing
You
up.
still
with
act
my
like a youth.
book and my apple for the teacher. Right? Okay, so when you're in Sunday school and you're dozing off, and they're like, and Derek, what do you think about that? What's the answer for that? And I didn't hear the question at all. I'm just like, oh God, right?
CCP.
Right? If you're me in that situation, what do you answer with?
CCP.
Is the answer Jesus? And they go, yes, Derek, good job. Pat me on the head and give me a piece of candy. Yes, did it again. Thanks, God. Right? In here, CCP is that type of answer. If you don't know the answer, odds are it's CCP. Okay? So how do we know that angle A is congruent to angle B? By CCP. And here's why. We proved that the triangles are congruent, right? So now we're allowed to use CCP. You have to prove the triangles are congruent first. Because if they're the same, then they should have parts that match up. The question is which ones do. Well, we're saying that these two match up. How do I know? This is why it's important to write your letters in the right spot. You see how A and B are in the same spot?
Then CC.
They're corresponding, aren't they? They're in the same relative position, which means they're congruent. Swag box.
What's CCP stand for?
Corresponding congruent parts. Corresponding means they're in the same relative location. Congruent means they're congruent. Parts mean they're parts of a triangle we've already proved congruent. Yes?
This was a while ago, but I never learned what that box was because I wasn't here.
Swag box. It just means I'm done with my proof.
So you
So,
always have to-
professional mathematicians either write Q, E, D at the end of their proof, which is some Latin phrase which basically just means proofs in the pudding. Or they do a box. Now, me,
Like pudding.
being me, I was like, well,
Ate stuff in the game.
swag. I do a cube. So double box just means I'm done. I don't know, people like it. I call it a swag box. I had a kid invent it. Shout out, can't remember what your name is. Do I even remember your last name? I used to call you by your last name. You have an older brother. Your older brother's a senior. You're a sophomore this year in Indian Creek. Shout out to you for coming up with the swag box. Anyway, that's it. So let's go over it.
What a weirdo.
Let's walk the concept. So, first thing we did is we took a regular triangle with two equal sides, right? That was what was given to us. And we said, let there be a perpendicular. And we did. You can do that whenever you want. You have powers to create it whenever you want.
Teleportation.
So let there be one, such that it's perpendicular to AB. Did it. Therefore, CD and CD are congruent to themselves because shared side. Do I have you up to here?
Yes.
Gentlemen, put your phones away.
He will take them.
Why are you doing this to yourself, bud?
Like he took
You know it's not going to end well.
He took
Like, I'm not going to tell you to put it away and get mad at you, but, like, we know, right?
Yeah.
Right? You know when you're in, like, elementary school, and they're like, let's do a science experiment. If I microwave the mac and cheese, will it cook it? That's my hypothesis. I think it will. And then they do the experiment, and they're like, oh, look, it did. Experiment success, right? If you already know what's going to happen, you don't need to do the experiment.
No, it's a
The experiment is, I can be on my phone. My hypothesis is it'll be fine. We already know this isn't going to end well. We already know.
If your ice cream is too frozen, just put your spoon in the microwave.
This is true. Although actually, yeah, do that all the time. Don't do that. I swear, don't do that. Guys. Metal in the microwave, not good, right? But like, yeah, we already know, guys. We already know, right? Like, who are we kidding? All right.
You.
No, you're not. All right, so we get up to here. Alex, for those of us joining in, right?
Alex is gonna
So you're allowed to make a perpendicular line whenever you want. So Alex, what I did is I said, let there be a line, and I'll call it CD, so that it's perpendicular to AB.
CD.
So I just said, let there be light, let there be line, okay? And I said it's 90, so says I. You're allowed to do that whenever you want. So we added that in, okay? Then I said, this guy is the same side for both of these triangles, right? It's a shared side. You follow me there?
Yeah.
right? So we're good up to there, right?
Yeah.
Decker, you with me? I know you're not, but are you with me now? Great, okay. Then I said by linear pair theorem. Okay, what does linear pair theorem mean? It means if we have two angles on a line, that means they add up to 180. Danny, not right now, I got them on a roll, okay? So if they're on a line, they're going to add up to 180. That's what this means. So therefore, this must be 90, right? If that is 90,
What is wrong?
Daniel.
That was a bad shot.
Remember, my rule at the beginning of the semester, first semester, is get funny or shut up. It applies to this too.
I threw my thing.
You're not being very funny.
I threw.
You're not. So I just need you to be clear. Please stop.
I'm saying.
I know. And it's better that way. All right, so LPT says they're 180, which means what's left over is 90, right? If that's 90, that's got to be 90. You dig? That's LPT. That's the reason for it. You with me, Alex? Okay, cool. Next I can say HL. Remember, HL only works for 90-degree triangles. So I have two 90-degree triangles. Now I can say their hypotenuse and leg matches up, right? Hypotenuse matches, leg matches. So they must be congruent. So now I know this triangle and this triangle are congruent, so I wrote that. I made sure to match up my letters accordingly, okay? Yeah. Lastly, by CCP. This means if I've proven the triangles are congruent, which I just did, that means their parts are congruent. So which parts? Well, A and B are going to be congruent because they go together. See how they're in the same spot?
C.
So once you've established that this is true, that the two triangles are congruent, then you can say, oh look, same spot, same measure. And that's what allows you to do it. CCP. Better?
Yeah.
How about you?
Is that a postulate at the top?
At the top, this thing right here?
Yeah, let there.
It is, yeah.
So
You can create
what,
one.
No, what's it called?
We don't call it anything. We just say let there be.
Okay.
Okay? Let there be line possible.
Why do we need to write CD as congruent to CD?
So that we know we have a leg that's congruent. So we know the legs are congruent, right? Because of this. And we know the hypotenuse are congruent because it gave it to us. So now we can use HL, right? You have to have legs matching, hypotenuse matching, and it be 90. And now we have that, we can say this. You did? Yeah. Great question. Do I have you at about 50?
Yes.
Okay, I'll take 50. That's not bad for the first day, guys. Do I have you about 100 up to here?
Yes.
Okay? The weird part, obviously, the new things we've done the shared side before, is the let there be line, right? You can do that. You can create a 90-degree line anytime you want. Remember those auxiliary lines we used to draw for those weird angle problems, right? You can draw a line whenever you want, and you can say it's 90, so says I, right? You can do that. That's fine. You have to be careful when you do it, because it can make things weird, but in general you can do it, okay? So now we're going to prove the converse. So instead of starting with sides equal and getting the angles, we're going to start with angles and get the sides, okay? We're going to prove it goes both ways. Something, something, something. All right, cool. Turn the page. So we're given a triangle, and it doesn't matter what triangle shape they give you, okay? It's a generic triangle, yeah? Yeah, what's up?
So there would be my, or you have to do let there be. I'm talking about you.
Oh, yeah, we'll get there, we'll get there.
Oh, okay.
Try to predict it ahead of time, see if you follow me. You know what I mean? That's a good idea. That's good, that's good, that's good. All right, so here's what we're going to do. We're going to start with ABC, just a random triangle, right? And they tell us that A and B are congruent, so we're going to start here. Now we need to prove that CA and CB are congruent, so that these two sides are, right? Obviously, if we were allowed to use Isosceles Triangle Theorem, right? We could just write, by Isosceles Triangle Theorem, CA is congruent to CB. And we call it a day. But we're trying to prove that. So it's like a definition, right? Where it's like, define dog. Well, a dog is a dog that, you can't do that, right? You can't use the word in the definition. We're not using the theorem in the proof of the theorem, okay? I want you to try this on your own, okay? Go get them. If you have questions, first of all, work together, right? It's about what, who you do it with, not what you do, right? And then I will also come around and help, okay?
Trash.
Yeah.
Just alright.
Alley-oop. This is.
That's how we invented the alley-oop. Go traffic.
Oop me.
Just cut reasons.
talking about CD. Or no. This one, yeah.
Yeah, in the case.
What am I gonna do?
So, they can't talk about this angle. So we're talking about this angle. And you can't even talk about that until you create it. Right? That makes sense. So first we'll say, let this happen. Right? And we'll call it D. Right? C, right? And then we'll talk about this angle here.
By me.
That.
I made fun of you.
I want to stay.
Yeah. So we let this be perpendicular.
There's a hole in here.
That's 90, which means that's 92, right? By LT. And then what we would say is shared side, and then we'd say now HL. So before you can say HL, remember it needs to be a 90-degree triangle. It needs to have the hypotenuse and the leg match. Right. So yeah, exactly. So like watch for order and the flow for your logic, right? That's gonna be something you're gonna struggle with, but you're gonna be okay. But again, the three things we need, because this is the key, right? We want to get the triangle. So if we want to get here, what do we need to be able to say next? Well, we need 90-degree triangles, so I created by doing perpendicular, right? I need a shared side for a leg, right? And then I need shared hypotenuse right there. Or no, they didn't give me. I need to prove that, right? So you're not going to use HL. They didn't give you. That's all we have right now. Okay. Right. Let me see. Hold on, guys. Hold on a second.
Alright, what did he say? We make up a line.
Hold on a second. Hold on. I might be missing some information here. Let me make sure that we're good to go. Nope, we're good. Yeah. You can prove it without HL. You can't use HL. You don't know anything about the hypotenuse. Remember, we're trying to prove that these two sides are the same, so you're not going to use HL, right? Because HL would have you know this ahead of time. You don't have that. You're going to use a different triangle theorem.
Because how was I supposed to know it was
But we know the angles ahead of time.
You do. You know a couple of angles, right? You know these two. Make sure you put those in your diagram, because that's given to you. Andre? Those are given to you. Make sure you put that in your diagram. Right? That's going to change things for you. How you're going to be able to do stuff. Okay?
Okay, so it's supposed to be up top.
I know this is weird and different. You've never done it before. It should feel that way. It's okay to feel unsure. We want you to try it as best you can so you can figure out what your intuition is, and then we can mold that. Right? If I just show you it, it's going to be dumb, right? But if you come up with something and then we adjust it, you're going to learn a lot better.
I got lost.
You look like that one
Can we just
kid
put
from the
C-
one vine with the ears.
Oh, yeah.
Can we just put CA equals CB by CCP?
Can I do?
Hold on one second. I'm going to answer his question.
Oh.
Yeah.
So, can we just put this by CCP?
No, you haven't proved the triangle's congruent yet. Step one, you have to prove you have to eventually prove the triangle's congruent, and then you can use CCP. You can't use CCP until you prove the triangle's congruent. So step one, get as much information on the diagram as possible. Draw that perpendicular, right? Step two, prove the triangle's congruent. Step three, prove their parts congruent with CCP. I'll give you a couple more minutes to work on it, and then I'll show you. It should feel weird. I want you to give it your best shot, though. Okay? If you have questions, raise your hand.
Okay.
Yes.
So
We just did what we did last time.
It's very similar.
Is like
these are congruent.
What do I look like?
I don't know.
Yeah,
I
so
got
CD's
lost.
congruent
I
by
got
shared
lost
side.
here.
Yeah. And so now you know how can you prove the triangle's congruent?
Other than that,
Of course.
well, they're congruent by side angle.
That's not side angle angle. If you go to the side of this angle, I had to skip an angle and a side to get there. Right?
Well, your mom's gonna be like,
Yeah, now the triangles are congruent, which means we can prove their parts congruent, right?
yeah.
Yeah, nice job, Millard. Alright, sorry.
Why should you do that?
For this, so it's
When you guys can stick, no, when you it's because Peyton's an Indian. When Peyton used to ask me to stick to this, he used to do that. Yeah, you know, that's me. He's the most obvious. So they'd be so like, don't like, how would you ever come up with that? Like, I hear the finger go off, I'm cooking corn. Hey, man, you're going on. Stuff like that.
So what's gonna happen here?
I'm using your pen. I'm using your pen.
By shared side, this is the same, right? And now we can say the angle on the side.
Yes, I'm using two of them.
And now the triangle is the same. Your parts are the same. Yeah, exactly. That's gonna be good. That's totally gonna fall for something like that, okay? Watch closely when I do it, because you've got a lot of extra here and it's a lot out of order. Order matters, okay?
You were being serious.
We're trying to present a logical argument, right?
I forgot to type that stuff.
You ready?
I took David's
All right, kid with the vine.
Stuck in there. They're like little things.
Hey.
Right, what is that?
Hey.
Yeah,
Is it?
got stuck in
Is that the kid with the ears?
No, that's
And
big.
he's like,
Oh, isn't that?
No,
isn't
he-
it-
he-
I know what you're talking about. He goes,
I won't hesitate. Right?
I
No?
won't hesitate.
Watch
to
it.
do something
Yeah.
else.
Jessica, I swear. Right?
Yeah. I won't
But he has a different
hesitate.
vine where he's like,
Yeah.
doing this. Yeah, you look like him. Anyway. So, here we go.
Screenshot the gun picture.
First of all, we're going to use let there be line.
Is this live?
Yep.
Probably be a screenshot.
huh?
I'll find the gun camera.
Oh.
Finger guns. Fortnite.
Alright, so let there be CD parallel to AB.
I just put the CD perpendicular to AB in the parentheses.
What? You have to say let there be. You can't just say, hey, parentheses, CD is parallel to AB.
I thought you said
Let is important because it says we're creating something.
Yeah, why
Okay?
let there be?
Then,
Pretty sure this was.
we're going to say CD congruent to CD. How do I know CD is congruent to itself? By what?
Shared side.
Shared side. Shared side. We can't use CCP until the triangles are congruent. We haven't proven that yet. Okay? By shared side. So we know this to be true.
Basic.
Then we're going to say, honestly, you could do linear pair theorem to say that this is also 90. Or you could just say, hey, I made it 90 degrees, we're good to go. So it's up to you. By LPT, measure of angle ADC equals 90. Right? And now we have enough to prove the triangle's congruent. Does everybody see that? We have angle, angle, side now. So now we can say the triangle's congruent. So, by angle, angle, side, triangle ACD is congruent to triangle, well, if that's A, it's going to go with B, BCD. And then lastly, what are we going to do?
By CCP,
By CCP.
CA is congruent to CB.
That's right.
Oh, I did that part.
Which is exactly what they wanted, right?
I did that part right.
I actually got it right.
Swag box.
Wait, can you show us what the angle side is?
Before we have this,
Your mama.
angle, angle, side,
Alright,
right?
that's from last
That's the
week.
proof of Isosceles Triangle theorem. Now, the beauty of theorems is that once you've proven them, you can use them as long as I tell you you can, right? So from now on, if you see two sides that match, you know the angles will match. And if you know two angles match, you know the sides match,
Just
right?
your big head's in the way.
My big head is in the way?
Yeah, I can't see.
Yeah, that happens sometimes.
CA, Capricorn. Caribbean.
If you want, you can scoot over, Daniel. How do we feel about that?
I got about halfway.
Cool.
I'm learning.
I'm going to get you some proofs toolbox stuff, but for now, here's some quick stuff, okay? First of all, some quick definitions. That's the definition of midpoint, right? It cuts a segment in half, right? So we can say B is the midpoint of AC by definition, right? Everybody agree with that idea? Right? BD is a bisector of AC. Bisect means to cut into. Sect means to cut, right? Sectum sempra, right? Pretty bad people, no?
Yeah.
Right? And then bi means to, right? So we cut in half. So DB is cutting AC in half, which then implies that B is the midpoint, right? Now we don't know what angle it's hitting it at, right? It could hit it at a weird angle like this, right? It still cuts it in half. That's still a bisector. Now, a bisector that hits it at 90, we call that a perpendicular bisector. Does that make sense? A bisector, something that's cutting it in two, that hits it at 90 is a perpendicular bisector. Everybody cool with those concepts? Now, not only can we bisect segments, but we can also bisect angles. Right? We can cut angles in half. So in this case, by definition, DB is the bisector of ABC. So here's ABC, it's an angle. And I put DB in it such that the angles are equal on either side, which means DB is a bisector. It cut the angle into two equal pieces. Are we cool with that idea? Same thing as segment, just with angles. Same thing here. It turns out, I didn't write this in words, but it turns out that any point that's on the bisector of an angle will be the same distance from either side of the angle. So if I have an angle and I cut it in half, any point I put on here will be the same distance here and here, here and here, here and here, to the either side of the angle. So the distance from here to here is the same as the distance from here to here. When we measure distance, we always make sure to do it at a 90-degree angle, right? Otherwise, we'd be like, hey, it's longer here. Well, you got to measure at the same angle, right? So we measure it at 90. So if you have something like this, then we know what that means. That means that this must be a bisector. Must cut it in half. That's a theorem. We'll talk about that later. But those are some basic concepts. Do we understand the idea of bisector? Great. I got something for you. It's a little thick. We're not doing this for homework, not the whole thing. So relax. She thick. And she has a lot of problems, but that's okay. Nope. That was for your health. So if you're good, I'm good. Will I be asking you under quiz to prove that theorem? Oh, you bet. Right? Either one way or the other, probably. Probably not both.
So would you have a quiz on this on Friday then?
Not Friday. No, we're not having a quiz Friday. We're having a super quiz next Friday.
Why do we have a super quiz?
Here you go. Because it's going to cover stuff from this week and next week. We have an early release Friday, or no, we have the assembly, right? So we just really don't have enough time to do a week worth of material. So we're going to do a week and a half worth of material on the quiz next Friday.
I was gonna go take my quiz on Friday.
Oh no! I don't know what to do, bud. Danny, what sport do you play right now?
Basketball.
Basketball. Are you good at dribbling?
A little bit.
That's what I thought. You breaking ankles out there?
No.
No? That's good. Healthcare isn't free, guys.
That's what I did.
Otherwise we end up like community.
That's right. We hate that. Never any wars, free healthcare, maple syrup. Got it. Uh-oh. Sounds terrible.
And then I'm like,
For some reason, Canadian freedom is cheaper than American freedom. I'm not sure why. Maybe it's because Americans pay for it. Ooh, got it. All right, so. Hello. First of all, let's start with what they gave us. D and E are congruent. So that angle is congruent to this angle. Always mark your diagram with what they give you. All right, pals. It says A is the midpoint of DB. What does that tell us about our diagram? A is the midpoint of DB.
It's not on the scale. Wait, never mind.
Yeah, it does tell us that, doesn't it? What else? Yeah.
It has a bisector, or
Yeah, CA is a bisector of DB. That's true. So what does that mean?
Student taking your fire essentials during the fourth hour. We'll be doing announcements now. Please observe a moment of silence.
What else?
where's the
Oh,
flag?
she's great.
Please stand for the pledge.
Is this fourth hour?
no, we have to do what we're doing now.
To the flag of the United States of America. To the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Here are your announcements for Wednesday, January 22nd. Breakfast now will be breakfast burritos, juice, and milk. Lunch today is Salisbury steak.
So, if A is the midpoint of DB, that means these are congruent, right? Midpoint means cuts in half.
I even want more.
B is the midpoint of AE, so that means these two halves are equal. So they're all equal. That A is the midpoint, so those two are equal, yeah?
Wait, the entire
DA is the same as AB, because A is the midpoint of DB.
are you talking about the angles or the lengths?
Lines. B is the midpoint of AE, so if that's how long this one is, that must be how long this one is. All right, Using that information, we're going to prove the two triangles congruent. Which ones?
Hey,
The pink ones, you silly goose. We're going to prove those two congruent. How do you do it? I'll give you a hint. You're allowed to use Isosceles Triangle Theorem, and you should look at the bigger picture.
Shared sides.
No shared sides. We don't have any.
Oh, for those two.
Anybody see it? Zayden.
That entire thing is an isosceles triangle.
This whole thing is isosceles. How do I know? Two angles are the same, so their opposite sides are the same. So, by isosceles triangle.
Just a reminder that fourth hour, you will be doing the five essentials. Students in fact, you should have a link in your student ID number in which to take your survey with. And when the bell rings, we'll call the stage when you come to the office. Thank you.
How long is this survey gonna take?
By isosceles triangle theorem. CD and CD are congruent. Now, how do we prove CDA, the two pink triangles, congruent?
Because,
Go ahead, Luke.
well, the side angle angle,
Go ahead.
right? 'Cause those have to be
So CD and CE are congruent and A and B.
Something like that.
Yeah.
We need a triangle theorem. I need a three-letter acronym.
CCP.
Nope.
SAS.
Side, angle, side, side, angle, side. So by side, angle, side, triangle CDA, we're into triangle CE. Swag box. I want you to try number 2 for homework.
Hey, let me count this.
Alright, so the big deal for this one was don't forget about the big picture. A lot of you guys are like, oh look, 3 triangles, and forgot about the 4th one, right? In fact, there's more than 4. But this is an isosceles triangle because these two angles are the same. So I can use isosceles triangle theorem to say these are the same, right? If two angles are the same, then the opposite sides are the same, and vice versa. Best of luck on number 2. We'll talk about it more tomorrow. See you later. Good. Ellie, if there's anything I can do or any skulls like to crack, just let me know, alright?
What? Who won?
Who won?
Derek won? Who in
I
your
hope so.
class brought in $94?
None of your freaking business. How do you know?
Because you're so. It's on student council.
Yeah? Did we win?
How much did Miss Howard's class have?
Not $94, I'll tell you that much.